All right, spacemans, buckle up because today we're taking a deep dive into a cosmic enigma that'll leave you saying, wait, what?
I love it when we get into the weird stuff. Ready when you are.
So, you know how people picture moons as these kind of boring, pockmarked rocks just hanging out? Well, Uranus has this moon, Miranda, that's like, hold my space, beer, I'm about to blow your mind. And you know I love a good planetary mystery, so I dug into the research you sent over.
Excellent call. It's not every day a moon this small throws such a massive curveball at our understanding of, well, everything.
Right, we're talking tiny, like 470 kilometers in diameter, barely a hop and a skip on a cosmic scale. You wouldn't expect much geological action on something that small, right?
Exactly. It's like planetary physics 101 smaller worlds cool down faster. Less internal heat, less geological activity, end of story.
Mm.
Or so we thought.
Yeah, Miranda missed that memo, didn't she? She's got canyons, ridges, and then there are those, what are they called again? The coronae?
Corona, it's like someone took a giant ice cream scoop to the surface. These massive oval-shaped regions, some of them hundreds of kilometers across. Absolutely bizarre for a moon this size.
It's like finding a miniature poodle that can bench press a car. What could possibly cause that kind of dramatic landscaping on a tiny moon like Miranda?
Well, imagine the force that moves our ocean's tides. Right now, crank that up to 11 and you get tidal heating. It's like a cosmic tug of war with Uranus pulling on one side, maybe some of the other Uranian moons on the other.
And all that gravitational energy has to go somewhere.
Exactly. It gets absorbed by Miranda, creating internal friction that generates a ton of heat, enough to melt rock, create those wild surface features we see today.
Wow. Okay. So tidal heating, that's one for the books. But there were a couple of other possibilities too, right? Like the research you sent mentioned something about radioactive elements.
Right, so that's our good old reliable radioactive decay. Think of it like this slow-burning furnace in Miranda's core. It's been going for billions of years, releasing heat as elements break down.
So even on a small world, that constant heat source could keep things cooking under the surface.
Exactly. And then there's residual heat. Think of it like a baked potato hours after it comes out of the oven. It's cooled down on the outside, but deep inside, it's still holding on to some of that initial heat from its formation.
Okay, that actually makes a lot of sense. So we've got these incredible forces shaping Miranda tidal heating, radioactive decay, residual heat. It really drives home that what we see on the surface is just a tiny snapshot of what's happening below.
Exactly. And that's why Miranda is so important. It forces us to rethink our assumptions about how planetary systems form and evolve. If a moon this small can have such a complex geological history, who knows what else is out there?
It's like the ultimate lesson in don't judge a book by its cover. Or in this case, don't judge a moon by its size.
Hmm.
So by studying these quirks, these anomalies on Miranda, what can that tell us about, say, our own solar system?
Well, it tells us that even the smallest players in our cosmic neighborhood might be hiding big secrets. Secrets about how planets form, how they evolve, and maybe even secrets about the potential for life beyond Earth.
Wait, hold on. Are you saying those crazy ice volcanoes on Miranda could be a clue for finding aliens?
Not exactly on Miranda itself, but think about it. If tidal heating is happening on this seemingly insignificant little moon, it could be happening on a much grander scale on other icy moons like Europa or Enceladus. Moons that we know have vast oceans of liquid water hidden beneath their icy shells.
Whoa. Okay, now things are getting really interesting. So by studying Miranda, this little weirdo moon in the outer solar system,
We could unlock bigger secrets about the potential for life in our universe.
mind officially blown. This deep dive has been a wild ride, and it just goes to show sometimes the most unexpected places hold the biggest clues about the universe. Don't underestimate the power of a weird little moon.